Hi ladies, looks like we have another snow day on our hands, so we're going to continue on with the notes. Now we're going to move on to quickly review about impulse and momentum, and then we will move on and talk about conservation of momentum. Okay, now really quick, before we even get started, think about conservation of energy. We did conservation of energy in the last chapter. Conservation of momentum is very similar. Okay, now this slide just reviews with you the basics of impulse and momentum. Remember, impulse is equal to a change in momentum, okay? And momentum can be either a vector or a scalar quantity. If you use speed, it's a scalar quantity. If you use velocity, it's a vector quantity. So all this slide is really explaining is the connection between momentum and impulse. So the question is posed: if an object goes from moving in one direction, stops for a brief second, and then moves in another direction, which has a greater impulse? Does it have a greater impulse if you're changing direction like that? Or is it a greater impulse if you just stop an object, okay? Like catching a football. So look at it as two different scenarios. Look at it as a volleyball player hitting a volleyball back over a net, or me catching a football. Which one has more impulse? Well, it actually has more impulse to change directions than it does to just stop something. Okay? If you want, you can kind of figure out the mathematics behind it by just simply plugging in numbers for both. But just know that it takes more impulse, more momentum to change directions than it does to stop an object. Okay, now we're moving on to that conservation of momentum. Some quick reminders. We talked about conservation of mechanical energy before. Now, what we mean by conservation is, conservation means that it remains unchanged. It remains constant. So however much momentum we have before something happens is equal to however much momentum we have after something happens. So if you look at this equation here, I have the momentum of object 1, initial, that's m1 v1 I, plus the momentum of object 2, initial, that's m2 v2 I. And that is equal to the momentum of object 1 final, m1 v1 final, plus the momentum of object 2 final, that's m2 v2 final. And another example of this is going to be the gun and bullet scenario. We talked about the gun and bullet scenario when we talked about Newton's third law. It's still the same objective. Okay? The gun has a really large mass, so when it recoils, it's going to recoil with a small velocity. But the bullet, since it has such a small mass, okay, is going to move with a large velocity because the mass is so small. Now let's move on to the sample problem. This sample problem is for conservation of momentum. So you have to look at a few things here, okay? You have to keep certain things straight. So you're going to have a mass 1 and a mass 2. Make sure to keep those straight. You're also going to have an initial velocity 1, initial velocity 2, a final velocity 1, and a final velocity 2. So the hardest part about these problems are keeping everything straight. Okay? And once you go through one or two of them, you're going to understand what I mean. So in this sample problem, it says, a 76 kilogram boater initially at rest in a stationary 45 kilogram boat steps out of the boat and onto the dock. If the boater moves out of the boat with a velocity of 2.5 meters per second to the right, what is the final velocity of the boat? Now envision here that the boater is stepping out to the right, and when he steps out, he's pushing the boat backwards to the left, okay? So your final velocity of the boat will be negative because it will be to the left, okay? The next slide here, I'm going to show you actually how to do the problem. Okay, as you can see in the sample problem, I have everything set up for you. Mass 1 is going to be the mass of the boater, that is 76 kilograms. Mass 2 will be the mass of the boat, that is 45 kilograms. VI1, so that's the initial velocity of the boater, is 0 because he is at rest. V2I, which is the initial velocity of the boat, is also 0 because it says that the boater is initially at rest in a stationary boat. So both the boater and the boat are initially at rest. V1F is the final velocity of the boater, which is 2.5 meters per second to the right. So it's positive. So we want V2F, which is the final velocity of the boat. Okay? As you can see here, you can follow along. I've done the problem out for you. Try it on your own. See if you get the same answer. Hopefully you do. Okay? You are using the same equation, that conservation of momentum equation, for your sample problems that you are going to do individually. Okay, as you can see here, I've given you hints on how to do the sample problems individually. It's sample problem D, numbers 1 through 3. I've given you hints on all of them. I'm also available through email. I've gotten a few emails from a few different people who have emailed with questions about how to do the last sample problems. I am more than welcome to answer any questions over email, but these will be due the next time I see you. And I will be grading them for correctness, both sets. So make sure to ask your questions now or come see me when we get back before your class starts. Okay? Enjoy the rest of your snow days.